Last time we learned the three growth models. Now comes the real challenge. Can you recognize the model instantly? Can you build the equation from real data? That's what actually shows mastery. Recall the three growth models. Unlimited growth, where the growth is proportional to the current size. So y prime will be equal to a times y. And if the initial condition y of 0 equals c, then the solution will be y equals c times e to the power at. Then we have limited growth, where the growth is proportional to the distance from a maximum. So y prime will be equal to a times m minus y, where m is the maximum. And if the initial condition y of 0 equals 0, then the solution will be y equals m times 1 minus e to the power negative at. And then for logistic growth, the growth is proportional to both the current size and the distance from a maximum. So y prime will be equal to a times y times m minus y. And if the initial condition y of 0 is equal to m over 1 plus c, then the solution will be y equals m over 1 plus c e to the power negative a times m times t. Let's see if we can identify the model. In this problem, we want to find the solution y of t by recognizing each differential equation as unlimited, limited, or logistic growth, and then we'll find the constants. So in part A, we have y prime equals 1/3 y, and our initial condition y of 0 equals 9. So here we can see that it matches y prime equals a y. That will be the unlimited growth model, where a is 1/3 and c is 9. So the solution will therefore be y equals 9 times e to the power t over 3. In part B, we have y prime equals 3 minus 0.01 y with initial condition y of 0 equals 0. Where here we can't directly see or identify it as one of the three models, but if we rewrite y prime as 0.01 times 300 minus y, then we can see that it matches the limited growth model, where a is equal to 0.01 and m is equal to 300. So therefore, we can write our solution as y equals 300 times 1 minus e to the power negative 0.01 t. Now in part C, we have y prime equals 1/3 y times 1/2 minus y with initial condition y of 0 being 1/6. So clearly it matches the logistic growth model, where a is 1/3 and m is 1/2. So in order to solve for c, we'll use the initial condition, where y of 0 equals 1/6, and we know that y of 0 is m over 1 plus c. So since m is 1/2, in order to solve for c, we can multiply both sides by 1 plus c and divide both sides by 1/6. So 1/2 divided by 1/6 is 3. Therefore, c will be equal to 2. So our final solution will be y equals 1/2 over 1 plus 2 e to the power negative t over 6. Let's see how this applies. A coin collection initially worth $2,500 grows continuously at the rate of 6% per year. We want to find a formula for its value after t years. So first we need to identify the model. In this case, we have continuous growth at a fixed rate, so that will be the unlimited growth model, where a is 0.06 and c, our initial value, is 2,500. So our solution will be v of t, if we say the value with respect to time, that will be equal to 2,500 e to the power 0.06 t. Now, a business estimates a maximum of 5,000 followers. Starting from 0, they gain 1,200 followers in 10 days. we want to model the growth and estimate when they reach 3,500 followers. So first we need to identify the model. It starts at 0, but it approaches a maximum. In this case, there's only 5,000 followers maximum. So that will be an example of limited growth where M is 5,000. So if we define this by n, the number at time t, that will be equal to 5,000 times 1 minus e to the power negative at. Now we can solve for a using the information given to us in the problem. So they say starting from 0, they gain 1,200 followers in 10 days, meaning when time equals 10, the number of followers is 1,200. So if we let 1,200 be equal to 5,000 times 1 minus e to the power negative a times 10, because now t is 10, we can solve for a. So first we'll divide both sides by 5,000. So 1,200 over 5,000 is 0.24. Then if we do 1 minus that 0.24, that'll be 0.76, which will be equal to e to the power negative 10a. In order to solve for a, we'll need to take the natural logarithm on both sides and divide by negative 10. So a will be equal to negative 1 over 10 ln 0.76. Now that we found a, we can estimate when they reach 3,500 followers. So in order to solve for t, we want to set n to be equal 3,500. So looking at our equation, 3,500 will be equal to 5,001 minus e to the power negative at. In this case, we already found a. So we can divide both sides by 5,000. That will be 0.7. And then if we subtract from 1, that will be 0.3. So e to the power negative at will be equal to 0.3. And in order to solve for t, once again, we'll need to take the natural logarithm on both sides and divide by a. So t will be equal to 10 times ln 0.3 divided by ln 0.76. And that will be approximately 44 days. Now, a music video spreads through a school of 2,500 students, beginning with 10 students. By day 3, 150 students have watched it. We want to find a formula and estimate the views after 7 days. So first we need to recognize what type of model this is. This is a bounded population because there's a maximum of 2,500 students, and we have a non-zero start because it starts with 10 students. So this would be an example of logistic growth, where M is your maximum of 2,500. So we can define our solution as P, let's say population with respect to time. So P will be equal to 2,500 over 1 plus C e to the power negative 2,500 times A times T. So given the condition that we have, we know that it begins with 10 students, meaning at time T equals 0, the population is 10. So we can solve for C using this condition if we let 10 be equal to 2,500 over 1 plus C, because when t equals 0, this will be 1. C will be equal to 249. Now that we know C, we can find a formula and estimate after 7 days. So in order to find A, we'll use the second piece of information that's given to us in the problem. By day 3, 150 students have watched it. So when t equals 3, P equals 150. So we can let 150 be equal to 2,500, 1 plus 249 e to the power negative A times 2,500 times 3. So doing some algebra, we know that e to the power negative 7,500a will be approximately equal to 0.063, and taking the natural logarithm and divided by negative 7,500 on both sides, we'll find that a is approximately 0.00037. So now that we found C and we found A, our only unknown is T. So P of T will be equal to 2,500 over 1 plus 249 e to the power. That negative 0.925 will be the A times 2500. So that would be negative 0.925t. So in order to find the number of students who have seen the video after 1 week, we simply substitute t equals 7 into our equation, and we'll find that there's approximately 1,807 students who have viewed the video after 1 week. So how do we identify the right model? Is growth proportional to y only? Or is my differential equation y prime equals a times y? Well, that will be unlimited growth. Does growth depend on the gap to a maximum? Or is my differential equation y prime equals a times m minus y and it starts at 0? Then that would be an example of limited growth. Or does growth depend on both the current size and the gap? If that is so, the differential equation will look like y prime equals a times y times m minus y. And if you have a non-zero start, that will be logistic growth. The key to mastery is instant recognition. Look at the structure of the differential equation and the initial condition to determine which model applies before solving. Math isn't just solving equations. It's modeling how the real world behaves. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.